OSI reference model. Most networks are based on the Open Systems Interconnection Standard. This is set out in 7 layers that define the different stages the data must go through to travel from one device to another over a network. The layers are divided into 2 sections: the lower layers, which are the transport set, and the upper layers, which are the application set. These layers are the physical layer, data link, network, transport, session, presentation, and application. Layer 1. Physical. The physical layer controls the signaling and transferring of raw bits onto the physical medium. Physical layer provides a specification for a variety of hardware: cabling, connectors and transceivers, network interface cards, wireless radios, and hubs. Layer 2. Data link. The data link packages the higher layer data into frames so that the data can be put onto the physical wire. The packaging process is referred to as framing or encapsulation. The encapsulation type will vary depending on the underlying technology. Common data link layer technologies include the following: Internet, token ring, FDDI, etc. Layer 3. Network. The network layer controls the internet work communication and has 2 key responsibilities. Logical addressing provides a unique address that identifies both the host and the network that the host exists on. Routing. This determines the path to a particular destination network and then routes data accordingly. 2 of the most common network layer protocols are Internet Protocol, IP, and Novel Internet Work Packet Exchange. Layer 4. Transport. The transport layer does not actually send data, despite its name. Instead, this layer is responsible for the reliable transfer of data, by ensuring that the data arrives at its destination error-free and in order. Protocols provide several important services: segmentation and sequences. Data is segmented into smaller pieces for transport. Each segment is assigned a sequence number so that the receiver's device can reassemble the data on arrival. The image on the right shows a large file can then be segmented into smaller files. Another important service is the connection establishment. Connections are established, maintained, and ultimately determined between devices. Acknowledgements. Receipts of data is confirmed through the use of acknowledgements. Otherwise, data is retransmitted, guaranteeing delivery. Flow control. Data transfer rate is negotiated to prevent congestion. Layer 5. Session. The session layer is responsible for establishing, maintaining, and ultimately terminating sessions between devices. If a session is broken, this layer can attempt to recover the session. The session layer performs the following functions: communication with the presentation layer above, organize and manage one or more connections per application between hosts, and communication with the layer below. Layer 6. Presentation. The presentation layer controls the formatting and syntax of user data for the application layer. This ensures that data from the sending application can be understood by the receiving application. Standards have been developed for the formatting of data types such as text, images, audio, and video. If 2 devices do not support the same format or syntax, the presentation layer can provide conversion or translation services to facilitate communication. Examples of presentation layer formats include text, images such as JPEG and GIF, audio, MIDI, MP3 or WAV, and movies, MPEG, AVI, and MOV. Layer 7. Application. It provides the interface between the user application and the network. A web browser and email client are examples of user applications. The user application itself does not reside at the application layer. The protocol does. The user interacts with the application within its turn interacts with the application protocol. Examples of the application layer include FTP via an FTP client, HTTP via a web browser, POP3 and SMTP via an email client.